120 kilogram car skids to a stop across a road surface which has a coefficient of friction of 0.967 with respect to the tires. Determine the acceleration of the car in meters per second squared.
So basically, we need to find acceleration of the car. To do this, we need to start with a free body diagram. So if this is our car, here's our free body diagram. To the bottom, we have force of gravity, and this is always present in objects, and it is 9.8 times the mass of the car. And because it is standing on a road, something is pushing it up, so that that would be force normal, and that is the upward force. And these forces must balance because the car is standing in place on a level. And because the car is moving this way, force of friction is the opposite way, or to the left, and force of friction is the force that is stopping the car.
The information we have given is mu equals 0.967 and the mass equals 1,120 kilograms. This may not seem like much, but we know that mu equals force of friction over the force normal. And we know how to find force normal because force normal is equal to the force of gravity, as we can see in the free body diagram here. Force of gravity, force normal. So in order to find force normal, we know that force of gravity is 9.8 times the mass. 9.8 times the mass. This is equal to this value.
So now that we have force normal, which is of this value, we can solve for force of friction. Now, force of friction is equal to mu times force normal, and that can be seen here. This is also equal to these values. Mu times force normal equals force of friction. And now, since we have the value of force of friction, we need to find a relationship between force of friction and acceleration, the value which we are trying to find. So, force of friction is equal to F net, since it is the only force on the free body diagram that is going to the left and right. This is equal to F net.
Now that we know F friction is equal to F net, we can find acceleration using this equation. We know F net, we know mass, all we need is acceleration. We rearrange the equation to find it, and we get 9.48.